Hey everyone, welcome. Today we're excited to have two exceptional leaders with us. Guillem Clofent, Managing Director at Mespack, and Silvia Gonzalez, Director of Software at Emerson. We are thrilled to gain insights into the groundbreaking work they're doing in packaging technology and software innovation. Thank you so much, both of you, for joining me. Let's start out by asking you to introduce yourselves and tell me a little bit about what you do at your company.
Thank you, Pat, for the nice introduction, and Silvia for inviting us to be here. My name is Guillem Clofent, and I am the Managing Director of Mespack, a leading company that supplies solutions in the primary packaging and end-of-line arena to the consumer product brands in the world, the multinationals that we all know.
Excellent. Silvia?
Yes, of course, Silvia Gonzalez. I'm the Director of Software for Emerson. And we design solutions that are future-proof for our customers to provide visibility, profitability, efficiency. So very glad to be here with you guys.
Thank you both for those introductions. Let's dive right in and talk about your recent project at Mespack. What did that involve?
So the main goal was to develop a modular visualization system that help our operators and the maintenance team that take care of our machines, the machines that we sell to our customers, to get a better use of the machine. And that was the reason why I decided to team up with Emerson Movicon Next solution.
Can you give me a specific example about a challenge that you were working through and how that went?
Well, I could provide several examples. I would pick one that I think it makes our relationship with Emerson very interesting. Our customers, they choose different PLC platforms, and of course we need to adopt their preference. So one of the most important challenge was to make our controls platform agnostic to each kind of PLC solution. And we were able to do that thanks to the Movicon Next technology, and on top of that we built our own software platform, which we name Athena.
Okay, that's perfect. Silvia, that leads right into you. Can you tell me a little bit about Emerson's Floor to Cloud solution?
Yeah, definitely. I mean, the Floor to Cloud solutions really is about collecting data from the sensors and the devices that are out there in the manufacturing floor and collecting all of that information into one visualization tool that enables production managers, operation managers, to visualize and have data-driven insights to make decisions.
So important to have that visibility. So Guillem, can you tell me how you see your project fitting into the Floor to Cloud approach?
So our vision is pretty aligned with the Emerson Floor to Cloud approach. Look, our customers, when they use our machines, they generate a lot of data. That data stored in a cloud infrastructure and put in their hands will provide them meaningful operational insights.
So how did the integration of this platform really sort of like enhance the decision making for your team?
Well, we see that as an enabler, right? Our Athena platform on the Movicon Next platform generates the possibility that our customers have access to the data in a structured manner, so they are aware of the trends, they are aware of for instance, the unplanned stoppages. By looking at the data and making a deep analysis, they can learn how to better use the machine, how to better plan maintenance programs. At the end, they will get more from the same asset. That is the ultimate goal of Athena using Movicon Next technology.
How do you think that this technology will evolve in the future? What do you see for that?
Great question. Look, we already see a bright future. It's a great present with a brighter future, especially when we think about artificial intelligence-based algorithms working with IoT sensors that we are using in our equipment. Look, we will be capable to deliver substantial and meaningful competitive advantages to our customers, just because they will get a higher efficiency of the systems that they will use.
Thank you, Guillem and Silvia, for sharing your insights and expertise with us and giving us an inside look at the exciting innovations coming from Mespack and Emerson. Seeing how this advances packaging technology and software solutions to meet the industry's evolving needs is truly inspiring. So for those interested in exploring these cutting-edge solutions and discovering how they can benefit your business, we invite you to visit emerson.com. You'll find valuable resources and opportunities to connect directly with our experts.
Thanks for having me. Hi, I'm Jonathan Mitchell. I'm an applications engineer here with Emerson's Discrete Automation Group. I work with our valves and our controls and software portfolio, but today I'd like to talk with you about HMI design. The idea for this talk came when I was spending some time with one of our integrators. We were at an end user that did chemical manufacture and processing. We went to their end of line where they did dispensing, and they had about 20 or so valves, quarter turn manual valves, and they were about 12 feet up in the air. And their process for switching over lines was an operator would grab a shepherd's hook and reach up there and manually flip a valve, and it would begin dispensing. Multi-million-dollar chemical plant, shepherd's hook. If that sounds familiar to some of you, that's all right, right? But it made me think that in most facilities, you have machinery that ranges from brand new, still being commissioned in some cases when you're there, to very, very close to end of life. And in those facilities, it is the management's responsibility to look at those machines and think about what are we going to do to keep from having to shut down, right? Most facilities don't want to shut down. So they have to consider, are they going to completely replace it? Are they going to do some sort of retrofit or modernization? And that's what got me thinking, because usually in this modernization process, the HMI is a bit of an afterthought. Usually the HMI could get a hardware update, right? Someone will put in a new monitor, a new physical interface, but the project running on it is generally left completely untouched. And that is done by design. There are good reasons that people don't do that. However, I'd like to challenge that today. I would like to share with you a little bit of experience from a past career of mine doing design and build of web applications and interfaces. I'd like to share with you some of the principles of user experience design and talk about how when you apply them in an industrial setting, it will help you cut unexpected downtime out of your schedules, reduce the chance of a costly mistake or error, minimize the amount of training time that it takes to get an operator from brand new to comfortable on a machine. And then once that operator is comfortable on a machine, it makes them as fast and efficient as possible, and they're content with using that interface. At the end of this, I'll talk a little bit about why I think Emerson's Movicon platform is a great tool for achieving these goals. So before we jump into the how, I'd like to take a quick look at the what, right? User experience design, which is oftentimes shortened to UXD. I will use the two terms interchangeably today. It's a relatively niche topic under the umbrella of design. And if that's new to you, that is 100% okay. As I said, it's a niche topic. It began getting popular in the early 2000s to 2010s and has remained more or less on the periphery of design since then. So when I say design, I think what most people immediately tend to think of is graphic design, right? Graphic design is a line of thinking which affects the look and the feel of an application or a tool, right? It's about what shape will a button be or what color will something be. In the early 2000s, as most of us remember, computer graphics had a bit of a revolution. It was spurned by a couple things, but one of the biggest was large, clunky displays started to give way to smaller, lightweight, high-resolution displays, which allowed people to see graphics if they were made nicely. At the same time, graphic packages, right, the tools that graphic designers use to make their graphics, became more widespread, and the barrier to entry got lower than it had ever been before. So seemingly overnight, for anyone who was on the internet in the early 2000s, websites went from being just sort of blocks of text to overflowing with graphics. And for those who were not on the internet at that time, it's hard to imagine this. It was everywhere, though. There were sites that were entirely graphic, which was a huge departure from what we had seen before. And user experience design sort of emerged on the scene to rein in a little bit of this chaos, right? It sort of stands not in a direct opposition, but it frames every design decision made with the question, how does this affect the user and what they're trying to achieve right now, right? It's a very user-centric design philosophy. So let's take a look at industrial HMIs through this lens of user experience and put ourselves in the shoes of an operator who is using an HMI day in and day out in a facility, okay? First and foremost, right, you'd like your interface, the tool that you use, it should allow you to do your job quickly and efficiently. A lot of times, this makes that you need to make sure as a designer that you're putting information where it's expected by the user, right? But you also need to put controls alongside that information to allow the user to make decisions based on what they're seeing, right? There should generally be a fair bit of back and forth when you're designing these interfaces. And I know that sounds arduous, but I promise you, it's not as bad as it sounds, and it can start well before you ever start to formally make your HMI on a computer. I start this process actually with a sheet of paper and a handful of Post-it notes to make sure that as I'm laying things out, it makes sense and the information is near the controls that affect it. Beyond being able to do your job quickly and efficiently, as an operator, I'm sure you would agree, you would like the interface to make it hard for you to make an error. The second biggest thing I would say is minimizing the ability for the user to inadvertently do something. After that, I would say the interface should be easy to learn, right? Whether you're a veteran or it's your first day on a job, you want to be able to get into an interface and handle it without having to kind of feel lost, and it should feel intuitive as you get through it. After you learn it, you would like the interface to be memorable as well, right? If you go on vacation for a week or 2 weeks, or you get moved to another cell for a handful of months and operate different machinery but are asked to come back, you want to be able to retain the information that you had before, right? It shouldn't take very long for you to get back into the swing of things operating your machine. So once all those major milestones are met of making it quick and efficient, not prone to errors, easy to learn, and easy to remember, I would say you have a pretty good HMI on your hands. But I would also point out, it is very important to keep the line of communications between the design side and the operators themselves open, on a regular basis, right? This is at the heart of continuous improvement, which I know a lot of people think is very important in an environment like this. So it's important to constantly ask those questions, are you happy with this? Are there things we could improve on? Because if an operator, right, if you're an operator and you're not happy with the amount of control that you have over your machine, or you're not happy with the information that's being given to you when you're expected to make changes in a machine, then that HMI is failing to do one of its most fundamental jobs. It is a human-machine interface. If we're not concerned with what the human feels about it, let's scratch it. Just call it a machine interface and get it over with, right? So I mentioned that user experience design is more common in what I would consider consumer-facing applications and websites, right? There are several reasons for this. For one, there are a lot more consumer-made apps and websites designed in a year than there are HMI or SCADA systems. Open the phone that you have in your pocket, go to the App Store, and you will see way more than you'll ever use. We don't design HMIs in such excess. But when they are designed, I also see that they are usually designed in a like-for-like manner. That is, they are generally replacing something. If they're replacing a previous digital HMI, they tend to take all the same controls, put them in exactly the same place, and maybe they move to a new software package because on the back end, it's more efficient or it's less computationally intensive. When they are replacing an analog control station, knobs, levers, dials with a HMI, it's oftentimes that they just kind of pick up everything and make a digital clone of it and give that back to the operators. And the explanation for that is not a bad one, right? Oftentimes, the excuse that I hear is that they want operators to feel comfortable on the new interface that they're being given. And that's a very valid idea. But I would also propose that another way to make your operators feel comfortable with what they're using is to include them in the design process and take their feedback as the system evolves. One of the big things that you lose when you imitate physical controls like for like on a digital interface is one of digital interfaces probably strongest points, in my opinion. And that is, and this is going to blow your mind, tabbed navigation. I know that this is not actually groundbreaking, right? Open up any web browser you use, open up any app on your phone, and it's super common to see things broken out by like tabs. For some reason, I don't see it as often in HMI design. And people do it for a great reason, right? It helps you take a large amount of information and break it down into much smaller sections. We can fit more on a simple 11-inch display than you could have ever fit on a massive manual console that was full of knobs and levers today, right? So why don't we make use of that? Tabbing things out also helps with one of the things that we talked about, right? Helping the operator focus on the task at hand. By keeping information front and center and the controls that affect that information nearby, you do minimize the chance that the operator is going to do something in error. And if they do make an error, the information's right there. They're able to see the effect of the change that they made in real time and compensate for it as nearly to immediate as possible, right? That should be a priority of ours when we're designing these interfaces. One of the big things that I don't see people do is kind of declutter when they upgrade, right? Some of these interfaces can be covered in information with knobs and dials and gauges. If you move from an analog control station to a digital space, you should pull things to be, near information that is related to what they are, but you can also suddenly take what would be an overwhelming wall of information and break it down into much easier to consider small bites. That helps with reducing that training time. Your operators are no longer sitting there sorting through a bunch of information that they don't know what to do with. Being consistent across your designs is also hugely helpful, right? Adopting a standard navigation, right, on all your HMIs in your facility. If you put navigation across the bottom, if settings are in the same place, things that we see, again, very commonly on our phones and consumer-facing websites, they're just not as common in industrial HMIs. And people nowadays are preconditioned to accept navigation and settings management the way that you see it on a web browser or in an app. So my advice to you is imitate it. But above all, make sure that you are taking feedback. Again, I know I'm driving that home a lot. Always take feedback from your operators. If they come back to you and they say something like, can we just move this one button a little further away than the other? Because when I'm wearing my gloves, it's really easy to hit the wrong one by accident. That's great feedback to get, right? At Emerson, and I'm sure as your companies as well, we value safety. We would not want an operator to have to choose between doing their job safely and doing their job properly. And when the solution is something as easy as move two buttons a quarter of an inch further apart, that seems like low enough hanging fruit that it warrants a redesign, okay? I think I've established now that by adopting a user-centric mentality, you can cut down on unexpected downtime, reduce the likelihood of an accident, minimize the amount of training that it takes to bring an operator up to speed on a new interface, and then make sure that when that operator is up to speed, they're quick and efficient and content with the interface, right? So now I'd like to talk a little bit about how I think Movicon addresses those issues and why I think it's such a standout development environment specifically. For starters, a lot of users see too much data. I know I talked about the perilous wall of data. That's true for HMI operators. It's also true for SCADA system users. Movicon offers built-in a reporting tool and alarm management and dispatching. I think that that's a huge help because it gets the information out of the sea of data turned into an actionable item and in the hands of a decision maker faster than it otherwise would have gotten there without any human intervention in between. There are also a growing number of specialized packages available for Movicon. Currently, we're offering our ProLean and ProEnergy packages, which make use of Emerson's wide range of supported protocols to pull in information from devices across a plant, regardless of who built them and what protocol they might talk. We've got a laundry list of accepted protocols. And ProLean focuses on operational efficiency and minimizing downtime. ProEnergy focuses on monitoring energy and reducing waste as much as possible. The big thing that I talked about, I know, was iterative design, right? That back and forth between a designer and the operator who uses an HMI. Oftentimes, people skip this step or ignore it altogether because it can be extremely arduous, and that's understandable. But Movicon's got a couple tricks up its sleeve to make iterative design a bit of a breeze. For starters, it has a drag-and-drop library of symbols. These symbols are available from little, line drawing ANSI symbols like you would see on a schematic to fully animated little isometric graphics for someone who is more visually oriented. It also supports custom symbols, which can really help make a consistent look and feel for people, especially if you deploy them across multiple machines in your plant. But I would point out that the included symbols are a huge tool as well, because they can help an engineer who has absolutely no background in graphic design put together a functional, visual HMI with really minimum work. There's also what I mentioned before about kind of standardizing on a design language. Movicon supports taking individual screens out of one project and dropping them into another, but it also supports a couple of nice things when it comes to that thing that I talked about with tabbed navigation and menus. We can take a menu from one project and drop it into another project, and you might change what the individual buttons do, but it reduces the time it takes to develop that screen by that much because you're able to recycle old assets from previous projects. And it does support a couple of advanced features. We've got 3D capabilities for when you want to leave absolutely no guesswork to the operator and you want to show something exactly as they'll see it. You can load a 3D model in and highlight something if there's an alarm or point to it. All of this is done in an engine which supports HTML5, so we can take that same project that we built for our HMI and have it displayed on a mobile device, perhaps your operator's mobile device or a standardized tablet. It can also be sent back to a PC or panel PC in a control room as a SCADA system. So I think when you take it all together, Movicon offers you an agile development environment which really helps you achieve the goals that you've got for your facility.
Welcome to the Emerson booth here at PACK EXPO. We're thrilled to have you with us today as we explore some exciting advancements in factory automation. I'm delighted to introduce Franco Stephan, Director of Product Marketing for Emerson's Factory Automation. Thank you for joining us, Franco.
Thank you for having me. It's a pleasure to be here.
The AVENTICS XV valve system, which was initially introduced in Europe, is now available in the Americas. Can you tell me about the target audience for that and some of the primary challenges that they faced?
Sure. The target audience for XV valve system is machine builders operating across various industries, mainly factory automation, automotive, food and packaging, and tire. These builders face significant challenges nowadays, including the need for high-performance technology, the need for flexibility to adjust to changing market demands, and also the need to, and the pressure mainly the pressure to produce a variety of products while maintaining top quality. Additionally, they also need to scale their production in order to satisfy increased market demands.
Sounds like a challenging landscape. So how does the XV address that?
So XV has been designed with flexibility and connectivity in mind. It offers highest flow rate in a very compact and robust valve package. These features, these qualities make XV great to improve efficiency and performance of pneumatic systems. The huge configuration flexibility also offers customers to boost productivity while offering changes or customizations to their products and machines to customer preferences.
Excellent. So let's talk about some of the key features of the XV. Tell me about that.
So XV stands out for its compactness and its outstanding flow to volume ratio. We have two sizes, XV03, which has a flow of 350 liters per minute, and the XV05, which goes to 880 liters per minute. It is a reliable valve, long-lasting due to its use of AVENTICS core technology, and on the outside it offers heavy-duty features like metal threads in NPT or metric, aluminum base plate, and a very robust construction.
Anything else?
Yeah, customers can drive up to 48 solenoids per valve system, which is a remarkable feature. They can also select among various fieldbus protocols like Profinet, Ethernet IP, EtherCAT, IO-Link, among others. All this makes the valve system a very flexible solution for the machine.
That's impressive. Do you have any examples of how this technology was used?
Yeah, we had several successful implementations. For example, a leading automotive industry manufacturer incorporated XV03 into their production line, improving their efficiency due to its high flow rate. Another example was from the packaging industry. The customer had a very tight space available and a very high demand of flow. XV fit that space perfectly fine. Both customers were very excited and impressed about the ease to configure products with our configurator.
It's really great to hear real-world success stories. So for those people that are interested in learning more about this technology or perhaps even purchasing this, where would they go for more information?
So interested individuals can come to our website, search for AVENTICS XV, and they will find a lot of great information out there. There's also a link to our configurator, which is a best-in-class configurator. It allows customers to do a system layout of their valve. They will be able to get very important technical information like CAD documents, bill of materials, schematics, to speed up their machine development.
Thank you so much, Franco, for sharing your insights on the AVENTICS XV valve system. It sounds like a real game changer for machine builders.
It is. Thank you for having me.
And thank you to our audience for tuning in. To learn more and speak to any of our experts, please visit emerson.com for more information on the AVENTICS XV valve series and how it can benefit your operations. Hey everyone, today we're excited to introduce Emerson's utility monitoring display and its latest innovation, Energy Manager, a powerful tool designed to help users elevate energy and operational efficiency. We're going to explore how this solution provides real-time insights into energy usage and enables smarter, optimized operations. I'm Pat Lurie, and I'm pleased to be joined by Amit Patel, Director of Intelligent Automation at Emerson. Amit, thank you so much for being here.
Absolutely. Thank you, Pat, for having me. It's great to be here and for me to talk about our Energy Manager solution.
So, of course, energy challenges can significantly impact your bottom line and also your sustainability goals. Tell me a little bit more about those challenges.
Yeah, absolutely. So energy and utilities consumption usually is one of the largest overhead costs for manufacturers, compounded by the fact that you've got rising energy costs every year. In a typical manufacturing site, machinery and tools represent about 50% of the total energy that's consumed. And that's a major opportunity for savings that manufacturers can really begin to take a hold of and see value and potentially scale it with our solution. Another big issue today is that identifying those inefficiencies, especially around energy consumption, down to the machine level is pretty complicated and not that easy, because many manufacturers today are lacking the data to make the right decisions, accessing data and then unlocking it, and then also adopting new technology, all the while trying to prove ROI and accelerate towards those sustainability goals that they've set, whether it's to reduce emissions or achieve net zero.
So Amit, walk me through some of the key benefits of this solution.
Absolutely. So the Energy Manager is really designed to jumpstart and accelerate your energy savings journey. And the Energy Manager does several things. It allows you to unlock that trapped data and access it, contextualize it, and then visualize it so you could see anomalies, you could see consumption trends, the associated costs, and CO2 emissions. And the great feature about this solution as well is that it's scalable because it uses our edge hardware. So whether you want to deploy it on one machine an entire production line or several sites, you can. Furthermore, the Energy Manager is also designed to work with our Compressed Air Manager, and that further strengthens our ability to understand the resource consumption for your machines. Compressed air and of course electrical energy is used throughout a factory, whether you're doing packaging or processing. And with this solution, combined with the Compressed Air Manager, customers can really begin to accelerate their cost savings and reach their energy saving targets.
So Amit, tell me about some of the features.
Yeah, so some of the features with our solution is that you've got basically the sensors over here. This is our Emerson RSTI. It's a power meter and it's essentially creating the data. So it's providing the voltage measurement, the power measurement that gets sent via Modbus TCP. And over there, we also have the Yanitsa power quality meter, which is a third-party sensor that's using OPC-UA that is also able to create similar types of data around power, voltage, frequency, and send that information to our edge hardware. And our edge hardware is really where you have essentially the brains where you're collecting, you're computing, and then pushing that data to our software platform, which is what you see right here.
So where else have you used Energy Manager?
Yeah, so we've used Energy Manager in one of our sites in Europe. And a great aspect about the Energy Manager actually is that it's capable to be combined with our Compressed Air Manager. That really strengthens the ability to get a high-level overview of the type of resources that your machine is using, not only now electrical energy, but also compressed air. And generally speaking, with compressed air, there are inherent leaks and inefficiencies. About 30% of the total compressed air that's consumed actually, 15 to 20% of that goes to waste. So that's another area that manufacturers can really begin to tackle inefficiencies across their machines. And in this particular site in Europe, by combining the Compressed Air Manager along with the Energy Manager, we were able to reduce about $60,000 worth of cost savings for them for several machines.
So should we take a closer look at the dashboard?
Oh, absolutely. Yeah, so what you're seeing here is our user interface, and immediately you can see with the dashboard is essentially our home page. And you can see that there's effectively two machines or sensors that have been hooked up. You have the Yanitsa power quality meter, and then you've got the Emerson RSTI power meter. And what you're able to see is essentially the overall consumption distribution between the two. You can see the overall power demand over time. And as I go down the dashboard here, you're able to see consumption trends across different time ranges. Interestingly, it will also help you calculate the CO2 emissions and then also the costs that are associated with it. This allows manufacturers and users to really see not only the problem or the anomaly, but the magnitude and the scale of impact that it's creating, or loss, if you will, on your manufacturing site. Yeah. And you can take a look at some of the several features as well in the user interface on the left-hand side here, where if you click on the energy endpoint, you can actually do a deep dive on the actual sensor that's creating that data and then sending it to our industrial computer, and then of course to the software, and really get that depth of information perhaps that you need for that particular machine or that particular asset.
Thank you. We hope you're as excited as we are about Emerson's utility monitoring display. With the combined power of the Energy Manager and Compressed Air Manager, this tool offers real-time energy insights, help cuts costs, and drives efficiency improvements, all critical ingredients for a more sustainable operation. Now, when you're ready to take the next step, head to emerson.com. There you can dive deeper into our solutions and reach out to our team for a personalized demo. Let's work together to make your operations smarter, greener, and more efficient.